Hey guys, we are now here to know about Nand2Tetris Project. Now, I'll be discussing Project 1 Boolean Logic. Gate Logic. A gate logic means a gate architecture designed to implement a Boolean function. Elementary gates. Elementary gates are like AND gate, OR gate, and NOT gate. Composite gates involve AND gate and combination of AND gates and so on. Important distinction is interface versus implementation. We'll be given an AND gate, and from NAND gate, we have to build NOT gate, AND gate, OR gate, and then multiplexer, demultiplexer, NOT 16, AND 16, OR 16, multiplexer 16, OR 8-way, multiplexer 4-way 16, and so on. This is a hardware simulator where we are going to simulate each and every gate from NAND gate. Now let's start with NOT gate. NOT. Now we have to upload the chip of NOT gate and we have to load it. And then we have to upload the script of NotGet and then load it. Now we have to run the simulator and then we have to view the output. Now the output will be visible. Like if you give 0 as input, the output will be 1, and if you give input as 1, the output will be 0. Yeah, let's verify with truth table of NotGet. Yeah, and then next we'll go to AND gate. Now let's load the chip of AND gate and then the script of AND gate, and then we have to run the simulator. And then we have to view the output. If you see the AND gate output, if you give 0 and 0 as input, the output will be 0. If you give 0 and 1 as input, output will be 0. If you give 1 and 0 as input, output will be 0. And only if we'll get output as 1 when the inputs, both inputs will be 1. So we'll verify with this. Yeah, the truth table matches with the output what we got. So let's move on to the next one. OR gate. Now let's simulate OR gate. Let's load the chip of OR gate and then let's load the script of OR gate and then run it, and then let's see the output now. Yeah, if you see the output will be 1 if any one of the input is 1. So let's verify with the truth table. Yeah, if any one of the input is 1, the output will be 1. So the truth table is verified with the output. And next let's go to the XOR gate. Now let's load the chip of XOR gate and then the script of XOR gate and then run it. Now let's see the output. We got if any one of the input is 1, then the output will be 1, and if both the inputs are 1, then the output will be 0. Now let's verify with the truth table. Yeah, it matches with the truth table. So let's move on to the next one. Now let's go with the multiplexer. Let's load the chip of multiplexer and then the script of multiplexer. If you look at the code of the multiplexer, it will be a combination of 4 AND gates. Yeah, so now let's run it. Yeah, the running is completed, and then let's view the output. Yeah, this will be the output of multiplexer. It matches with the truth table. And then next we can move to the demultiplexer now. Let's load the chip of demultiplexer and then the script of demultiplexer. And if you see the code of demultiplexer, it will be the combination of 1, 2, 3, 4, 5 NAND gates. So let's run that. And then let's see the output. Yeah, this will be the output of demultiplexer. And let's verify with it. Yeah. Now let's move on to the NOT gate, NOT 16. Let's load the chip of NOT 16, and then let's load the chip of script of NOT 16, and then let's run it. Now let's see the output. This will be the output of NOT 16. And now let's move on to the AND 16. Upload the chip of AND 16, and then upload the script of AND 16, and then run it. And now let's see the output. Yeah, this will be the output of AND 16. Let's move on to the R16 now. Upload the chip of R16, and then script of R16, and then run it. If you look at the code of R16, it will be the combination of 16 OR gates, and the code of OR gate will be like combination of two NAND gates, and then run it. And now let's see the output. This will be the output of R16. If any one of the output is 1, it will be the 1. That's it. And next, let's move on to multiplexer 16. Load the chip of multiplexer 16, load the script of multiplexer 16, and then run it. And now let's see the output. This is the output of multiplexer 16, and this is the code of multiplexer 16. Combination of 16 multiplexers. And now let's move on to the next one, or 8-way. Upload the chip of or 8-way, load it, and then script of it, load it, and then run it. This will be the output of R16, or 8-way, sorry, or 8-way. Now let's move on to the multiplexer 4-way 16. Load the script of it, put the script of it, and then run it. And now let's see the output. This will be the output of multiplexer 4-way 16. Now let's move on to the next one, multiplexer 8-way 16. Let's upload the chip of multiplexer 8-way 16, and then script of multiplexer 8 by 16, and then run it. It's very simple. If you see the code of it, multiplexer 8 by 16 is a combination of multiplexer 4 by 16 and then multiplexer 16. Yeah, and now let's see the output. This will be the output of multiplexer 8 by 16. Next, let's move on to the next one. Demultiplexer 4 way. Yeah. Now let's upload the chip of it and then script of it and then run it. Let's see the output. This will be the output of demultiplexer 4 way. Demultiplexer 8 way. Let's upload the script of demultiplexer 8 way and then script of it and then run it. Now let's see the output of it. This will be the output of demultiplexer 8 way. That's it, guys. This is the end of project 1. Now let's see the project 2 in the next